here so I can see questions. Just a couple of housekeeping items before we get started. Several actually. I am using a new mic tonight, so if you cannot hear me, if I sound garbled, please let me know immediately. I have a backup headset, if that's the case. First thing. Two, I am getting over a cold, so if I sound nasally or if I start coughing, I'm all right. Just, yeah. And the third one is, this is designed to be a very open-ended presentation, so feel free to stop me if you have questions. Just raise your hand or drop something in the chat, and we'll go ahead and address that. So, without further ado, all right, Steve's already saying I should use the headset, so I'll do the headset. Watch it now. All right, please confirm you can still hear me.
Yeah, sounds good.
All right, we'll go ahead and proceed then. All right, so we're going to talk today about graph databases and just kind of get a sense as to how to use them and what they're good for. So as David mentioned in the open, my name is Jason Farrell. I'm a senior consultant where Microsoft Industry Solutions, which is the new name of Microsoft Consulting Services. I'm down here in Georgia, though I did spend 7 years in Chicago. Love the city, love deep dish pizza, but opted for warmer and more consistent weather here in Georgia. My blog, Twitter, and my GitHub, all of the code for the code examples I'm going to be doing tonight will be on my GitHub. I'll give the exact link at the end to that regard. So let's talk about databases. So as David mentioned in the onset, we have a lot of options. Of course, we all know the only real option is Excel, but we're going to pretend to talk about all those pretenders for a little bit right now. So we start off by talking about an RDBMS. So relational databases kind of got their start as a way to persist data. Now at the time, storage was very expensive, so we ended up with these normalized forms, which over time help us to avoid repetition and save space, which is not really much of an issue anymore. But regardless, in RDBMS, typically we are segregating the data into tables, columns, and rows. Very much a human-centric concept. And we have a high emphasis on consistency through ACID, atomic, consistent, isolated, and durable transactions. The whole goal of the RDBMS system is any given operation taking place guarantees that state is persistent after the fact. Now, the one key thing that often gets lost in all this is when we architect an RDBMS system, we do so for us, humans. The way that we conceptualize the data in RDBMS typically will follow the noun, verb, adjective model, meaning we are representing things in our head like a person's table or a certain relationships. That's how we perceive the data. That's very much ingrained because RDBMS has been around so long. That creates challenges. One of the challenges created by RDBMS is actually the consistency aspect, in that it takes additional cycles and it does not lend itself to the horizontal computing that we see today. And thus, NoSQL kind of came around the bend to actually offer an alternative to RDBMS. It's used a lot for ingestion scenarios. So, we have clients here at Microsoft that what they'll do is they will ingest large amounts of data into a NoSQL database and then process it later, organize it to an RDBMS. It's not unusual. Because what we're doing in this situation is we're not enforcing any kind of schema or structure, contrary to an RDBMS. Now in Azure in particular, our main offering is Cosmos DB, and we typically recommend it as a way to as we typically recommend Cosmos DB as not a good way to create a long-term storage, because the way the data is stored in a NoSQL database tends to be very expensive relative to RDBMS. Now, when I have this conversation, typically we go down the path of talking about how do you organize data. So remember, in the RDBMS system, we would organize it based on how we understand it. However, in a NoSQL system, we typically organize it to benefit the application. You see this a lot with things like partition key selection, where you ask the question, well, how will I read my data? What's the most common way I'm going to read and group it? And that tends to be your partition key, which we'll talk about in a little bit. Now, NoSQL prides itself on being highly available, but consistency tends to lack. In fact, this phenomenon was observed so much such that Eric Brewer, who's now a vice president at Google and a distinguished engineer, a professor at Berkeley, codified what's known as the CAP theorem. Curious if anybody on the call has heard of the CAP theorem before.
I have. Don't ask me to recite it though.
Yeah, Bob. So, the CAP theorem essentially looks at three key aspects of a database system: consistency, availability, and partition tolerance. And Eric's postulate, his theorem stated that any database system can only have two of these three elements in high supply. He stipulated that you'll almost never find an AC system because any system that's not tolerant of partition or network faults won't be able to, it's not going to be a very reliable system. So AC is out. Thus, the two systems that we often would see are a CP or an AP system. CP is mainly associated with an RDBMS. It is consistent and partition tolerant. AP is associated with NoSQL, highly available and partition tolerant. Now, for a long time, it was thought that rule was kind of true. It could only have two of these elements. But what we began to find, especially as the cloud emerged, is that wasn't actually true. It existed on a spectrum where you could have databases that had good availability and strong consistency, or strong availability but low consistency. In fact, in Cosmos, if you take a strong consistency setting, you are effectively creating a CP database. Whereas if you take the eventual setting, you are creating a pure AP database. Thus, the middle ground, which is session, is an amalgamation of all three elements of the system. So the rule of two becomes more of a guideline just to ensure that you understand that. So where does graph database fit into all this? Well, graph database is a NoSQL database, meaning it's designed more for availability than it is for consistency. So, and a graph database is typically it is built on the notions of graph theory. So out of curiosity, has anybody here ever studied or looked at graph theory in the past? Anybody? Well,
I see one thumbs up out there, so maybe a couple more.
Oh, okay. I'm not used to using Zoom, so I can't really see everything. But so in graph theory, we associate elements using what are called edges. So a vertex is associated with another vertex via an edge. In fact, computer science has a long history with graph theory. Most of our data structures would follow a graph type centric, a linked list, a doubly linked list, B trees. These are all graphs. But in terms of a database, if you think about the way this thing is, the way it's modeled, is it describes a relationship. And I think, and that's the key part of this, is that we can use the various pieces of metadata on the vertex or the edge to further give more meaning to that relationship. So for example, we might say somebody, his name is Sam, and he is a child of David. So, and typically the piece of metadata that we're most interested in here is the child of, which is a type of edge that we create. Now, in this case, the edge is what we call unidirectional, meaning it is always in the same line. So if you have like a B tree, that's how a B tree operates. There are also cases where we may want to have what is called a bidirectional flow, meaning you can go one way or the other. Different graph database providers will implement that in a different way. But what we can do is we can then add additional metadata onto each of these edges to give ourselves more information as we make traversals. Because that's really what you're going to do with a graph database, is you're going to traverse it to find the relationships that you want. Okay, so let's see this in practice. Think of a site like Facebook, and then think to yourself in an RDBMS land, how would I represent people liking a post? So if you go pure traditional, you would have a post table, you would have a users table, and you'd have a main and many here where the users and the posts are all doing this. Now, in that model, you're not going to get a lot of performance, because every time you want to look, in order to get the count of how many likes a post has, you have to join on the many-to-many table and do a count. Now, there are ways to get around this. You could flatten the table and just have a raw thing and index the hell out of it. But truth be told, that's where you start to see the breakdown of an RDBMS. In a graph database, we actually reverse this. Each user basically creates a liked relationship to the post. When we access the post vertex, we're able to count how many vertices, how many edges of a specific type are touching this vertex. So instead of having to traverse it all, we can look at the actual vertex and it knows how many edges it has. And we can simply ask, well, how many of those are of type like? So it kind of flips it on its head. So that's really what gives graph databases their unique advantage, is their ability to kind of find these relationships much more quickly than, say, your traditional RDBMS. Now, that's not to say that you can't do it in RDBMS. And I want to be very clear on that there's nothing you can do in a graph database that you wouldn't be able to do in a graph database, so in an RDBMS. However, with more options comes this idea of what is the best way to represent our data, the hierarchy. If you're dealing with hierarchical data, chances are a graph database is going to be better because of the way the edges are operating. But if you're dealing with tabular data sets, like a bunch of transactional rows, well, that's probably going to be an RDBMS. If you have a lot of different schemas coming in, that still might be a document NoSQL database, as an example. So again, it's just another tool in your tool chest. Okay, so any questions to this point, out of curiosity?
So I did have a question. Like, how do you compare scalability wise? Like, like being so many relationships, like won't it get at a point where too many relationships are there and like transactional, like we keep on adding data to databases? Can we use graph in such places?
So yes, that's the intention. So just to give some background, the original graph databases were created by, I believe it was Facebook or LinkedIn, one of the two. But the idea was just that it was designed to handle a large amount of data. In terms of scaling, the reality is that you'll see this in the code examples later. We want to partition the vertices. So when we start our query, it's not the same kind of conceptually as a RDBMS or even a NoSQL query where you're doing table scans. You're starting at a vertex or a set of vertices and you're starting to traverse. In fact, I have some information from the Cosmos product group around that very point, but it's a good question. But in terms of scale, they tend to be able to, given enough resources, operate much more efficiently than an RDBMS. But the trade-off is you don't typically want to associate a ton of metadata to each vertex. You may want to assign a subset of it. So as part of any traversals you might be making decisions. But for example, Sanket, if you were creating a org chart and each vertex represented an employee and had all the information about like pay, benefits, spousal information, name, birthday, hire date, you wouldn't put all that in the graph database. In fact, graph databases work very well. It's kind of a complement to another database system. Does that make sense?
Yeah, that does make sense. Okay, makes sense. Yeah, thanks.
No problem. Anyone
Hi,
else?
I have a question. What are some like popular implementations of graph databases that are, widely used?
You saw the next slide, didn't you? It's literally the next slide. Yeah.
Okay, let's go there. Thanks.
Yep, indeed. So great question by Steve. So graph databases are in heavy use today. The biggest vendor is by far Neo4j. They also have a GraphQL library, although GraphQL and graph databases are not the same thing. Just as a word out there, there are many, many other solutions out there. A lot of them are from analytics and machine learning providers. Graph databases are heavily used in AI and machine learning because of their ability to represent those relationships at a large scale. But the two big ones are Neo4j, as I already mentioned, and Tinkerpop. So Tinkerpop actually is the backing engine behind Gremlin in Cosmos and Neptune in Amazon. So Neo4j does have a managed offering and is available on Azure at least. It's called Aura. And you can actually go to their website and sign up for a free trial. And what you can kind of play with a managed graph database on your own. But it's very performant, but it's also proprietary. So they're not actually owned by any of the clouds. Tinkerpop, on the other hand, is widely open sourced and is in use by, like I said, Amazon and Azure and other providers as well. And it basically provides a bit of a more scaled down approach to graph databases. Now, it does that by leveraging a language called Gremlin. So Gremlin is the name of our offering in Cosmos for graph database, named after the query language that Tinkerpop uses. And the big thing to look here is you're looking at it follows very much the way that the mathematics of graph theory operate. If you've ever done research into graph theory, things like Dijkstra's algorithm for the traveling salesman problem, which is where, given the 48 continental United States, what is the shortest path a salesman could take to visit all 48 states? And there's various algorithms out there designed to find the right path. Now, a lot of those are the basis for like map and navigation applications. But Gremlin is structured in a way to work very much mathematically and in a way that I would call ETF-like. So you hit one vertex and you want to move to the next. And as you move over, you're doing different things, looking at different things. Each thing flows to the right until you eventually find your result or results. So we have different steps: mapping, filtering, and side effects. This one up here looks at the names of products created by two friends. Excuse me. But it's very procedural in nature in terms of what it does. I will say that if you're going to go into .NET programming, typically you are given the option through our SDKs to actually use this Gremlin syntax. It's essentially passed as a string into the Cosmos. However, there's a library out there called XRAM, and I'll give the link at the end, that actually makes this much more linkified. So it's much more easy to work with. And my code examples are all written using that. Now, speaking of Cosmos, I'll just remind you kind of what it is. It's a global scale database, although you don't have to turn on the global scale if you don't want to, and you can adjust consistency settings. Now, what that means is as you make changes to the graph and it wants to replicate out to other regions, strong versus eventual and everything in between is going to affect how quickly those changes propagate to your other replicated zones. But it's fully managed by Azure and has elastic scaling and throughput controls. Now, the one thing that the product group wanted to make sure that I was clear on when I discussed this is that when you make a query in Gremlin, it's not, it has to traverse. So depending on the complexity of your queries, be very mindful of throughput, because your throughput has to support what is potentially a lot of traversing through your graph, depending on how long it is, or rather how large it is, as well as the complexity of your overall query. So just keep that in mind. We don't have any levels to set, but just something to kind of keep an eye on. Serverless will, of course, kind of spit up to whatever it needs. So any questions to this point?
Again, Sanket, not a question. Like I was thinking scalability from this point itself. Like on our RDBMS side, we usually, if the database starts growing or we are hitting particular kind of queries, we start indexing stuff.
Mm-hmm.
But what happens when a graph starts becoming too big, where it has to traverse everything and it then starts slowing down stuff? Is it feasible to use in day-to-day places where you have a large amount of data?
Well, the answer to your question is yes, it's okay to use it there. But the more specific answer to your question is they don't scale the same way. What you're talking about is a table scan, essentially, and how that works. The way that graph databases work is in Cosmos is they're partitioned off. So if you've ever kind of studied how Cosmos works, and this is the same with Neptune as well, is that it breaks things off into smaller chunks, and then it can index within those chunks itself. So as it kind of gets larger and larger, it just kind of further partitions itself down and does like layered indexing.
Okay, makes sense. Yeah, thanks.
Does that partitioning also mean that it can use partition elimination to get rid of a bunch of the data that you can look at the query and know, I'm just not going to need all that, so I don't even have to look at it?
Right. Every node, every vertex in has to have a unique ID, just like a database. Now it's not a number usually, it could be a GUID or something, but the other part of it is that then you have the partition key, which is how it segments it. So one of the key things we always talk about with Cosmos is avoiding things like uneven partition keys or hot partitions, and trying to kind of spread it across pretty evenly. So that's why whenever you're doing not just graph database, but NoSQL in general, the selection of that partition key is huge. If you don't get it right, it's hard to change. First off, you can't change it on the fly. You have to create a whole new collection in Cosmos because it literally affects the way the data is being stored. What I did.
Yeah, I was just going to say, I mean, that's what it sounds like, is you really kind of have to know your data and know how your data is stored to choose that partition key correctly. I mean, you actually can partition data in SQL Server and Oracle too, and it's the same thing as
sharding.
You just said. Yeah, if you choose that partition key incorrectly, you actually will get really, really poor performance. So
correct. And and that's why, going back to the earlier slides where I said that when you start talking about NoSQL, you have to really know your data, because you have to organize the data for the application. And that point seems so simple, but it is incredibly hard to pull off consistently, because like you said, if you select the wrong partition key, you're going to have even worse performance. So it's kind of a double-edged sword. You have to really know how your application is going to be, reading and storing your data to use NoSQL. Whereas with RDBMS is on the whole, a bit more forgiving on that matter. Good questions. I always love these conversations about like this kind of stuff, because this is, this is really what we have to deal with when you start talking about much larger applications or that have high volume. So taking it back to Senket's point, your vertex have IDs, but they also have to have a partition key associated with them. You'll see me kind of do that here in a moment. And it just kind of keeps things, my examples are pretty small, but again, going back, you might want to say, I'm looking for an item of a specific, a specific classification, and that will spread it across. So you're not dealing with a long data set, but rather, 10, 12 smaller data sets. Exactly.
Makes sense. Thanks.
Yeah, no problem. So a quick demo here. I'm going to show you how to create a graph database in Azure. So let's go out to here. So this is what I'm going to use for my actual code demo. We'll hit create. And we'll go to Cosmos. So we go the same way no matter what. Cosmos DB. Now hit create. Now this takes a few minutes, so I'm not going to make you. I'm not going to make everybody watch. Excuse me. So here's the one we're looking at here. We've got NoSQL. This is our document DB store. Supports a SQL-like syntax. MongoDB. These two are basically the same, just from Mongo. Cassandra is. Oh, I would forget what they call Cassandra. But that's too bright. That's what they call Cassandra. I'm forgetting what they call it. Cosmos DB. This is table storage. Oh, go ahead. Do you know Senket?
Kind of a distributed system, distributed database. Right?
Yeah, it's a distributed, but there's a specific name for it. I just forget what it's called. It'll come to me later. Postgres, this is brand new. We just announced this at Ignite. That's in preview. And then here's Gremlin right here. So we'll press create. I'm going to put it in my RG graph. I always like to prefix mine with Cosmos DB dash test database, and I always give it a random string at the end. Just have now you can do provision throughput, which is this can be cheaper if you kind of know your load. If you don't know your load, pick serverless, which will actually let the service spin all the way down to 0 and have no cost to you or minimal cost when you're not using it. Don't need that. Not working. I'll just go ahead and create it. Rotate the default somewhere else, and we'll let it go. So that's going to go ahead and create that. I'll delete it later. Takes a few minutes to do it. We're not going to bother with it for right now. Let's go back to RG graph, and we're going to go into that one in a little bit. So this one's been completed. I think there's data, and I did put some data in here. So if I go into so you're always going to get this data explorer, which is always really nice. So you can see I have this music. Actually, you know what? We'll come back to this in a second. But you can kind of see that there's your graph. And like everything else in Cosmos, it's underneath a database. So you have a database and you have graphs. And you can have as many graphs as you want. Analogous to collections, if you're familiar with the terminology from the document DB side. So I'll go ahead and wait off on that for a little bit. So the $1 million question, when should you consider a graph database? Well, there's a variety of cases out there that do make a lot of sense. Mapping applications. You think about a system by which you could represent intersections as vertices, and then the roads connecting them as edges, and maybe have a traffic congestion quality on each edge, and that will allow you to kind of navigate through, on a map. And I think that's actually what I believe a lot of the mapping applications are actually based on, these type of graphs to a degree. Machine learning is absolutely huge with this, because you think about it, machine learning is all about finding relationships between data or different points. And literally I showed you two, Gremlin and Tinkerpop, but there's literally like 20 other graph database providers out there, and all of them are related to machine learning and AI. Because again, thinking about how do you train a model, how do you train what things are related to what? A graph database is going to be far better at representing that than say NoSQL or RDBMS in particular. Now, one of the other ones that was kind of cool to me that I was talking to one of our product group about was product compositions. So take an industrial machine. It has a lot of parts, a lot of moving parts. You can represent those moving parts in a graph, and you can associate diagnostic information with the edges. This would allow a machine to watch the graph and say, and do predictive failure analysis. That machine's going to fail. That part's going to fail. I need to order that new part. So there's a lot of different things you can do with that. There's actually a client in Chicago I'm working with, and they were looking at graph databases to represent workflows. Because again, you can really easily represent where a workflow went, what data was associated with each step, or what happened at each step. And the other one that is kind of nice is a recommendation engine, which I'm going to show you right now. But companies like Spotify or any of these companies that make recommendations, a lot of them use graph databases to find who you're connected to, and then say, well, if you're connected to this person and they like this, chances are you probably like that as well. And they use that to inform other networking conversations. Obviously, org charts and social networks. Can anybody here think of any other ones that might, other cases that might very well fit a graph database? Column oriented. I've not heard that before, but take your word for that, Steve. That was something else, but yeah. All right. Well, go ahead, Steve.
Maybe in like biology, where you have to organize like different, species hierarchical and kind of find out, what's related.
I think that's a great example. I love that. I might use that one in Vegas when I give this talk. I like that one. Nice. Anyone else? All right. So let's go ahead and look at a recommendation engine. So I have created an application here with a bunch of artists in it. Now, first, let's have a look at the actual data. So if you go into your Cosmos DB, you can click on the graph here. And here's your query. That's a Gremlin query. It says, give me all the vertices. Now you can pass a predicate in here and get a lot of different things. Now the nice thing is that you get this really nice flow. So it says Google Dolls alternative, which is just my way of saying like the artist with the genre as my ID. And then here's me. So if I pick Jason Farrell out of there, now this is going to start showing more and more relationships. So this is that vertex and all the edges that it has and the corresponding vertices that come with it. Now this isn't bad, but I like this tool instead. I forgot to open it before we came online, but come on. So this will show me one vertex that I select from the side, which is not overly helpful. This will show me everything once it opens. So George Strait, you can see that, well, it's not going away. Come on. Wow, that thing's taking forever to turn on. Anyway, wow. There it goes. All right. Oh, okay, so let's go ahead and we're going to go ahead and do a new query here. That's not, said you okay. Well, we're not going to use this maybe at all. I thought this thing was supposed to expire next week, but it's not going to. That's unfortunate. Oh, there it goes. It just didn't like me. So go ahead and run this query. Okay. All right. So first thing I want to tell you is that just because this thing is spitting out JSON it's not actually JSON behind the scenes. So don't make that mistake, because that will actually make it very difficult to add new things in. So those colors are amazing, but yes. So right here, you see, we have a bi-directional relationship here between myself and my wife. She's Korean, she likes BTS. I like the Goo Goo Dolls. Pretty cool. But you see all the indices are kind of laid out. Now that application that I use, let's just run through it a little bit. Come on. You know, you think for Microsoft, they give us better machines. You'd be wrong. Let's go ahead and create, let's go ahead and do this thing. So, all right, so let's go ahead and let's create an artist. Anybody want to throw it out an artist? I'll make web otherwise. Anyone?
Weird Al.
Weird Al. Okay, I like that. Now, what would you rather? How about do alternative? All right, so we'll do 3. So go ahead and added Weird Al. Okay, so if I rerun this query, should go faster this time because it's actually awake. Should. Yep, that was faster. So let's go ahead and pull that up, and we can see Weird Al over there. So let's go ahead and say I'm going to actually make a I'm going to do something here. I'm going to say I'm going to add in somebody here on the chat. Let's add in David Berry. Okay. Now, obviously, David, you like Weird Al. So
I have all of Weird Al's albums.
there's nothing to be ashamed of either about that.
Not at all. He's actually like one of the most versatile artists of the last 40 years with everything.
I believe that.
A biopic came out on him. It's a really funny comedy a few days ago on the Roku channel.
Oh, nice. That was a memories Christmas song. I want a hippopotamus for Christmas. Anyway, so here we have. So there you are, David. You're right there. Now, what I want to do is I'm going to see if I can. I'm going to ask for a recommendation for you. So you like Weird Al. So because that's alternative, it should request an alternative artist. So let's get a recommendation. So I'm going to ask a recommendation for David. You might like Goo Goo Dolls. Now, I have no idea if you like it or not. I'll no. But the reason to pick that is, and this is a very simplistic recommendation, just to be very clear, because it looked at yourself and said, well, you like alternatives, so therefore you must like other alternatives. So I hit no. So now let's get a recommendation from my wife. So 2. Now this is what's picking. You might like Skillet. So she likes BTS, which is K-pop. Skillet is, but there are no more K-pop artists on here. So it says, well, who are you connected to? You're connected to Jason, and Jason likes rock and alternatives. I'll pick one of those 2. If you like Metallica. So you probably like Skillet. Okay, so let's go ahead and say she likes Skillet. All right. So if we run that query again. So now she likes Skillet. Now let's go ahead and we're going to say that David, you like George Strait. Actually, first thing we're going to do is we're going to make a friend. You and let me see. So David, you can be friends with me. So what that did now is it brought David into the main graph. So these things starting to get complicated, you can kind of see here. So now that you're connected to me, Dave, and I'm going to change Weird Al to, well, let's put Weird Al as, well, I think this is because he's alternative, it's going to kind of mess with it a bit, but actually we can do is we'll add block Nelson. All right. So then we'll go ahead and say Brock Nelson likes George Strait. So Likes George Strait, 6. So now, and then we're also going to say that he likes NSYNC. So let's get a recommendation. So let's go ahead and run our thing again. You can see how it's getting faster as you hit it more because, yeah, it's waking up. All right, so we have a lot going on now here, as you can see. So Brock now selects George Strait and NSYNC. So that's country and that's pop. So it's going to be pretty. That's not what I wanted, but whatever. It's going to be pretty random here. Let's just do a recommendation for Brock Nelson. So it's going to recommend Taylor Swift. Now, why? I think Taylor Swift's actually labeled as, she's pop. So it said, you like NSYNC, which is pop. So you must like, and there, I found another one. There's no other country in here, but I found this, which is also pop. So you may like that. So I'll hit yes. But you can kind of see that the recommendation engine is you're able to kind of fan out and make determinations using the graph. Go ahead and minimize that. Now, how that all works is something called XRAM link. So right here, I'm basically setting up a connection to the Cosmos DB. And what I've done is I've created a bunch of these methods on here. They're all genericized to do the various operations. So what ends up happening over here is liked artists are looking at different steps. So first I say, given the artist, the genre you like the most, are there any that are among your connected friends that you like? So on and so forth. The other thing I want to point out, that's not what that was. There's GDO, oh, I closed it, is when I make a friendship, I'm doing a bidirectional. It's 2 unidirectional edges. Because you can't, Gremlin doesn't allow you to go back, at least not XRAM. So you kind of have to get these double edge vertices and kind of consider both sides, both directions. Okay. So all this code is available out there. You're free to run it. And there's a seed method to kind of generate your starting point. Let's go back. So I know I'm getting towards the end. We're all probably getting kind of sleepy. So let's go ahead and kind of finish off just talking through this. So right tool for the job. Great, graph databases are pretty cool, but they're definitely not designed for everything. So really understand that your use case, and I think the point was made a bit earlier. You have to understand your data, and that's true with NoSQL in general, but it's also very true when it comes to graph databases. And I even say to most of the clients that, remember, when you organize this data, when you think about the ways it's going to be queried, that is a direct correlation on how you organize it in NoSQL. In RDBMS, it's a bit more forgiving, but in NoSQL and graph, it can be very punishing if you don't make that decision correctly. Now, graph databases are really nice. You saw me kind of using it there, but I look at them very much as complementary systems, meaning you might use it to do a lookup or gather some, like IDs, and then go against your typical data store to pull that information back. Because where you're going to start to see a breakdown is you start putting 100 different key values on each of those vertices. Very heavily used in AI. I think that's pretty clear from what we saw, in that you're talking about a database system that really puts relationships first. And when you're talking about AI, when you're talking about machine learning, any kind of data analytics, those relationships between the data are more important in a lot of cases than the data itself. And I think that's where graph databases find the most usage and the most utility. When you really want to, when the value of what you're doing is more about how that data is related than the actual data itself. Okay, so here's some links. All the source code that I used is right there. Application's fully functioning. All you have to do is add the secrets and deploy a Cosmos DB database using Gremlin. I've got XRAM, got Gremlin, so that's what I use. When I use graph databases, it's much more friendlier to C# versus the Gremlin syntax. and what we provide through our NuGet libraries. And there's a list of all the graph database providers I could find. I think this is a pretty good list. It's definitely got AWS and Neptune on it. Sorry, Gremlin and Neptune. So I'll leave that up. I guess that's all I have for the presentation. Are there any questions from the group?
Yeah, hi, this is Steve. So like I haven't used Cosmo DB that much in practice. What would you say is like the most commonly used implementation of it? Because I remember you displayed 6 options.
Document
something like
DB
that.
Document DB by far.
So that's like their Microsoft's implementation of like what Mongo is kind of.
Yeah, it's a document database. So it's formerly Document DB. I believe AWS has one too. It's not Dynamo. They actually have a Document DB service, although Dynamo, I believe, is closer to our table storage. I think it's been a while.
Yeah,
But
yeah.
by far, go ahead, Dave.
I say if I could jump in, to me, I think the big use is because Azure doesn't offer a MongoDB, a MongoDB in the cloud. Mongo offers that with their Atlas offering, but I think a lot of people use, the MongoDB API with Cosmos because, maybe you have Mongo, on-prem and you want to be able to kind of do those same things in the cloud. I think that is the primary use. The important thing to know though about Cosmos is that you pick that access algorithm up front, and then you can't change that, right? You'd have to go and create a new Cosmos database.
Correct.
So if you pick that first option that you showed where it said document DB, then you'd be using the SDK library that has a very SQL-like syntax, to go through and access that, as opposed to whereas if you have applications that are already written using the Mongo driver, then you would want to choose that MongoDB option. To where basically you can just kind of lift and shift those apps. So
and there is an Atlas offering for Mongo offered through the marketplace. We actually had a client, state government, that was looking at that, and we did a cost benefit analysis for them. And given their use case, I believe year over year they would save about $3,000 on Atlas versus Cosmos. So, but the two of them are pretty close in terms of what they do. Again, with Cosmos, you're going to be fully managed by Microsoft. You have all the backup and then full integration to Azure. Atlas kind of comes with its own thing. But to answer Steve's question, it's by far Document DB, and that's actually what a lot of our training pushes to. Although that might change now that Postgres has been added to the mix, but I haven't used that yet.
Cool. So is using like RDBMS an option too with Cosmo DB, or do they just use like the?
It's just a SQL syntax. It's just a SQL syntax. But it's not. There's I'm going to say this tongue in cheek because I don't know about Postgres. There is RDBMS is not what Cosmos is about. That's what SQL. That's what Azure SQL, MySQL, MariaDB. That's what those are for. Obviously Azure Postgres. However, I was pretty surprised when I saw the Postgres offer at Ignite. Haven't had a chance to use that yet. I don't know if that's a Postgres NoSQL version somehow, or what. I don't know what that is, to be honest. Santosh will know.
Interesting. Yeah, I know that AWS Aurora will use like it's basically like their kind of super version of like Postgres that's very highly scalable.
Yeah, Aurora is more the serverless RDBMS, because I think it was MySQL for the longest time. We offer that as well with Azure SQL. There's a serverless option, although that's tongue in cheek because the way that SQL Server works, it never really spins down to zero, and it's not quite the same thing. So I can't speak to the Postgres or how you compare it to Aurora. Be an interesting comparison though, for sure.
Oh yeah, it's interesting to see how all these things are implemented in cloud-based technology.
Yep, we just keep copying each other. That's all we do.
So Jason, graph databases, there's quite a bit to learn here. And I guess I wanted to ask, how did you get started learning this? Maybe what are some good examples, whether those are, books or videos or maybe like sample applications to go work on, if somebody really wanted to dive deeper into this topic, what was kind of the path that you took, and what pointers would you provide to someone else?
I've always been interested in graph theory since I was in college. I took a lot of discrete mathematics, and I'm in the same boat as everybody else. I've tried to represent hierarchical data in RDB on like SQL Server, and it's a pain in the ass. So I just decided to look into it one day, and I watched a few YouTube videos, but for the most part, just dove right into it. And I guess lucky me, I have access to the product group and Mark Brown, and I can talk to people on the team and get direct answers for us. So that kind of helped out a lot. That's why I've tried to kind of build this presentation, because I think if there's not a lot of people who use it because they don't really understand what it's for. And I've tried to kind of craft this presentation to help people understand what they could use it for. And just, I would say the biggest pointer I'd give is, understand, how our data structures, how our search algorithms find things. It's kind of the same kind of, not a bubble sort. I think it's like a B sort or something. It's been a long time since I was in college. But they all use an element of graph theory to actually to solve these problems. And so I recognize a lot of the data that we're seeing with AI and ML is much more about relationships. And you look at a site like Facebook, and how that data is related to each other is more important in most cases than the data itself. So I think graph databases, that just kind of got me interested, and that's how I took off with them.
Yeah, I think that was interesting. One of the things that you said early on is, because when I think about relational databases, is you talked about how, it's nouns, verbs, and adjectives, but relational databases, and I've done relational databases for a long time, really the nouns are very, very prominent, right? Being in the table, but there are different problems out there where maybe the relationship should be more prominent. Mm-hmm. And, where things have evolved for the kind of the last 5 or 10 years is that rather than, it used to be that we only had the relational model and we just really kind of tried to hammer everything into that. And now, I think there were always kind of these databases, but maybe they're only used in academic circles, or they weren't really accessible, right, to kind of just like the everyday type programmer. But the great thing about the cloud is that it's not like, I remember, like downloading source and trying to get the stuff to compile, and it wouldn't compile, and you try to install it on a system, you get some strange error.
Yep.
You don't have to do that anymore, right? You can just go spin something up in the cloud in a few minutes. You can be messing around. Baby. You don't have to worry about backup all the way, availability. Yeah, all that stuff. So
I was back in my younger days. I would compile MySQL from source, compile PHP from source, compile Apache from source. I didn't compile. I was never crazy enough to compile Linux from source, but I had friends.
I used to swear a lot in my younger days when I did that.
I got a kid. I got a wife and kid now. I don't have time to wait for anything to compile. So.
I have another question. What would be the preferable way if you wanted to, put an endpoint in front of it? Would you use GraphQL, or would you use like RESTful APIs with Web API or something else?
So just as a disclaimer, I don't buy into a lot of the hype with GraphQL. I really don't. I prefer the REST endpoints, but to each their own. It really depends. I would say what it depends on is the way you're going to access the data. If you're going to, if you really want to do, so GraphQL is, from what I understand, useful when you have a lot of different ways data could be accessed or queried, as it were. And so you want to give the person who's querying the ability to kind of explore the data. RESTful endpoints are more, what the operations are, and you're going to go carry them out. So it kind of depends, I think, on that dynamic.
You said it correct. It's basically pick and choose for GraphQL, and it has a huge learning curve from what I see. Yeah. And frankly, I don't see it matters in this case, right?
Yeah.
Like whatever you use to connect on that thing. I had a quick question if other question is done. So the question is like even like few years back, like 4 or 5 years back, when I was completing graduation, I had done a little bit of dabbling with Neo4j, is Gremlin having the same language, this thing, for
So,
query?
so Gremlin is the language in Tinkerpop. That's what they
Okay.
actually call it, Gremlin. I forget what Neo4j calls theirs, but they are.
As I remember, it was something Cipher or something language
Yeah.
which was used for querying in querying the
Yeah,
relations or building
they're
it.
complete. Their syntax is completely different.
Okay.
I can tell you that for sure. So,
Got it.
yeah.
Doesn't Neo4j, don't they offer a version that you can just download and install on your machine, a
Yep.
free version? I mean, I think it's fairly limited,
Yep.
you know, you're not going to go run Facebook on it, right? But if you want to download that and kind of mess around with some of the concepts on your machine, I think they do have a version out there for that. So.
Yeah, I think so. I've only found they have a managed cloud version nowadays, so you can actually like spin it up in the cloud and just kind of play with it on their cloud.
I think, yeah, that was something which we used to use. You just log into their own server online and you can play around there.
Right.